Let's use a function machine to learn how to find the determinant of the 3 by 3 matrix, row 1, -4, -2, 3, row 2, -3, 1, 2, and row 3, 3, 4, -2. Here's a hint. The determinant of this matrix is -5. Clearly, we did not get -5 by taking the product of the entries along the main diagonal and subtracting the product of the entries along the minor diagonal, like we do to calculate the determinant of a 2 by 2 matrix. So let's see how the function machine actually outputs the determinant -5 for this 3 by 3 matrix. First, we need to do a little prep work and make a checkerboard of positive and negative signs for the entries of the matrix. Starting in the upper left-hand corner, we place a small plus sign next to the first entry. Next, we need to alternate signs along the first row, so we place a negative sign next to the second entry in the first row, and then a positive sign next to the third entry in the first row. Now we need to alternate signs in the first column. So we place a negative sign next to the second entry in the first column, and we place a positive sign next to the third entry. And we complete the checkerboard by alternating positive and negative signs along the remaining rows. Now we're almost ready to do the math inside the function machine. But first, we need to choose one row or one column to expand on. It doesn't matter which. Any single row or any single column will produce the same output, namely the determinant -5. And don't worry about what we mean by expand on. You're about to find out. Okay, I choose to expand along row 2. So we get rid of every positive or negative pink checkerboard sign that is not in the row we are expanding on. In this case, row 2. And now we're ready to do some math in the determinant function machine. We begin by considering the row or column we have chosen to expand on, in this case row 2, and focus on the first entry, -3. If the pink checkerboard sign next to this entry were positive, we would write down a +1. However, the pink checkerboard sign next to our -3 is negative, so we write down a -1. Now we multiply by the entry -3. Next, we mentally cross out the row and column containing the entry -3 in the matrix and use the remaining entries to multiply by the 2 by 2 determinant, row 1, -2, 3, row 2, 4, -2. Then we slap down a plus sign and focus on the next entry in the row we are expanding on. Since the pink checkerboard next to the second entry is positive, we write down a +1. Then we multiply by the entry, which also happens to be a 1. Next, we temporarily eliminate the row and column containing the entry we are focused on and use the remaining entries, in this case the entries in the four corners of the matrix, to multiply by the 2 by 2 determinant, -4, 3, 3, -2, and we slap down another plus sign and focus on the next entry in the row we are expanding on. Since the pink checkerboard sign next to the third and last entry in row 2 is negative, we write down a -1. Now we multiply by the entry 2, and we temporarily eliminate the row and the column containing the entry we are focused on, and use the remaining entries to multiply by the 2 by 2 determinant, -4, -2, 3, 4. Now we simply grind out the math inside the function machine. The first term is -1 times -3 times the determinant of the matrix -2, 3, 4, -2. And calculating the 2 by 2 determinant gives us -1 times -3 times the quantity, -2 times -2, subtract 3 times 4, and quantity, which yields -24. And for the second term, we have 1 times 1 times the determinant of the 2 by 2 matrix, -4, 3, 3, -2. And calculating the 2 by 2 determinant gives us 1 times 1 times the quantity, -4 times -2, subtract 3 times 3, and quantity, which gives us -1. And for the third term, we have -1 times 2 times the determinant of the 2 by 2 matrix, -4, -2, 3, 4, and calculating the 2 by 2 determinant gives us -1 times 2 times the quantity, -4 times 4, subtract -2 times 3, and quantity, which yields 20. So the determinant is -24 plus -1 plus 20, which is -5. In the next video, we outline how to find the determinant of a 4 by 4 matrix using the same method we just used for a 3 by 3 matrix.